Well, I've begun the teardown of my personal rig to build my personal rig. Yeah, that. So we're bringing Skunkworks back, and this is the GPU that was actually in my rig right now, the HS420 build for about the last 7 months. The thing is, it's been using liquid metal. And liquid metal is something that every single PCB expert that has ever done PCB repair has said, don't use liquid metal. So I'm really curious now, did it stay where I put it? I had a little moat I tried to do and I just tossed it because the foam kept tearing, but I did all the proper insulation of all the SMDs around the die. And I'm curious though, after having a big discussion with Der Bauer in Computex about the gallium effect and the corrosion that it can cause to different blocks, I'm curious as to how well the DeltaMate block has held up with liquid metal, his liquid metal by the way. And I'm curious, did it start to pit it? Did it start to corrode it? Because we had a big discussion about the different types of coating he uses specifically for gallium and non-gallium use cases. So, it's only been 7 months, but that's long enough for bad things to have happened regarding liquid metal. The GPU still works, so I know it didn't migrate to places it shouldn't be, but I'm curious now, how well did it hold up? And I'm gonna be reinstalling a new block and not using the DeltaMate block in my new build just because of aesthetics purposes. This is also actually the new Alphacool Core GPU block, not sponsored. I bought it, but here's the thing. It's like half the price of all the other blocks that you find on the market. Well over 400 bucks. This is in like the $225 range. Still expensive versus what they used to be, but a lot more reasonable than what modern blocks cost. So I'm gonna take a temperature hit by getting away from liquid metal and by going with probably a lesser dense block than the DeltaMate, but this is why I do these in my personal rigs. I gotta run them every day to see what they're really like. If you're building a PC that's meant to be seen, then check out the new Atlas P6 CG from Gemdias. This isn't just another fish tank case. The Atlas P6 CG features a massive 270-degree curved tempered glass design that gives you an uninterrupted view of your hardware from almost any angle. And for those of you who spend way too much on collectibles, don't worry, Gemdias thought of that too, and it actually includes a dedicated display platform with its own spotlight. Cooling is handled with 4 pre-installed ARGB PWM fans, and the chimney-style airflow layout that pulls cool air from the bottom and exhausts heat naturally through the top and rear. It also supports up to 360mm radiators, GPUs up to 425mm long, and even rear connector motherboards for a cleaner cable management look. You also get USB-C on the front I/O and includes an ARGB hub, adjustable GPU support bracket, and a dual chamber layout designed to keep your build looking as clean as possible. So if you want a case that's equal parts airflow, showcase, and conversation starter, check out the Gemdias Atlas P6 CG at the link below. I was to take you guys along for the ride on the teardown because my biggest concern right now with the liquid metal, what size is this, is the fact that, that's not right. I'm concerned when I go to take the block off. I have to be really careful. I don't want it to drip, because it can drip, on anything else on the board. I may actually throw the whole PCB in my ultrasonic cleaner with my lab grade isopropyl alcohol just to guarantee that it's all off. But it can turn into quite the nightmare if it starts to get in places you don't want it, because the liquid metal is just that, a liquid, and it moves easily. So I have to take this plate off the back of the card because the DeltaMate block replaces the weird chrome looking, where'd it go? I don't know where it is. It's somewhere around. Oh yeah, this guy. It replaces this guy with his, which ties into the block and everything. So I need to take this off. You know, if I were smart, I'd go get my little, sounds like a dental drill screwdriver. You know what? I am smart. I'm gonna do that. Open wide. So people always ask me, Jay, where'd you get this screwdriver? You'll never guess in a million years. It actually came with an Asus product years ago. I forget which product it was, but it came with it. It's also where I got like that Asus ruler made out of a PCB. I don't remember what product it came in, but when it comes to like doing the blocks and stuff, it's really nice because it's a low torque device, so you're not gonna over tighten things. In fact, it can barely loosen the screw, right? Charges on USB-C, it charges really quickly. It's got a little light on it.
And compatible with iFixit bits.
Mm-hmm. I'm not gonna really miss the matte material here, because look at that.
It looks like a mess on the camera.
Dust was absolutely like always sticking to this. We live in a desert. Dirt is everywhere. Skunkworks always gets dirty. The filters on that worked really well. Skunkworks does not have filters. So Skunkworks gets dirty. The dirty PC needs to be punished. Okay, that was the last screw. So this should be able to come off now. There we go. Oh, you see that little pancake flip I did with the, yeah, watch. Oh, damn it. Aw. So I want to put all my thermal pads back where they go. Okay, I'm gonna do this now though, because I do not want the block to pop off. There. All right, so it should just be the 4 perimeter screws, a couple here. So I'm gonna start, okay, really crank this down. Careful. Careful, Annie. Ooh. Careful, Annie. And look, that's why you insulate the SMDs around your core. Look at that ball that formed right there. I could have popped there right now, but still. You know what though? Holy crap. I'm going to assume right now it has not really had any negative effect on the core, on the material here. But look at this. You see this little like drip right there? That just happened right now when I lifted it up. So I need to make sure it hasn't gotten on any of the memory or anywhere around it. So I have to do a very thorough cleaning on this. And what I'm gonna have to start with is getting like the Q-tips and like trying to suck up as much of that as I can with the Q-tip. That way it doesn't just smear. Because if I put alcohol in there and wipe it, it's just gonna smear it around and it turns into a really nasty mess. But if I just do a quick wipe on the block, I think the block held up pretty well. I mean, it should. DeBauer, oh, look at that.
Wow.
Okay. I could have continued running this without a problem, obviously. He clearly designs his product with this kind of stuff in mind. So you don't actually wipe liquid metal, you just sort of reform it into a gianter ball. So this is toxic. Don't let it touch your skin and stuff. At least you shouldn't. I don't know a lot about his formula. I know it's, see how it's just smearing around? I know it's a protected IP of his, but yeah, isopropyl alcohol will neutralize it and then I'll be able to wipe it easily, but. Yeah.
And can't eat it?
Yeah, I mean, you can eat it. You can physically eat the thing, yes. You shouldn't, though. I don't think there's any sort of pitting or corrosion on there. Nice. Okay, so the block's pretty good. We can move this out of the way. Look, as somebody that's trying to learn machining and stuff, fuck you, DeBauer, with this being as good as it is. Seriously. I'm like, what the hell? Obviously, this goes through some sort of media blast or something afterwards, but I'm not gonna show you what my attempts at CNC have looked like so far. They're almost that good though. See, we'll pick up some of it, but if I can even just get it like moved over to where I can just get a big ball of it and let it glob up, then I can actually use the liquid metal needle and syringe to like suck it back up into the syringe. This is reusable. Like, what's on here right now? Sorry, Phil, but.
Stop! Ah!
It's like literally torture for you. Now these are Kimtech wipes right here, science brand. These are not tissues, right? This is very specific non-fibrous lab wipes. I want to see what happens. Okay, all right. Oh. I can hear the pain in your voice. You're like, oh, conduct a nut. Conduct a nut. Conduct a nut. Let's go. Conduct a nut. Like I'm losing my mind, okay? Oh, I fell back out. Now you might be asking yourself, Jay, why aren't you, if the liquid metal's okay, why aren't you using it with the new block? I trust that DeltaMate has designed the metal and the coating on this block to deal and handle the gallium. I don't believe Alphacool has done any attempt at seeing how well their nickel plating, because that's nickel plating, will handle it. And nickel plating gets broken down by the gallium, so yeah, it's not really sucking it up. Okay, so now what we're gonna do is the brute force method. Now I'm gonna use the Q-tip that comes with his conductonaut. This is a different type of material than normal Q-tips. This should allow me to, oh, gee, don't fling the thermal or the conductive stuff everywhere, would you? So I'm just trying to get this all over to one side. See how it won't, like, doesn't mix in with the alcohol, but the alcohol allows me to move it all around. See, that's getting all over here in the corner. Now I do have a clear acrylic polish all the way around the core. That's why none of the liquid metal that like leaked over onto it affected anything in a negative way. Simply because of the fact that it is got an isolation barrier.
It seriously looks like the worst.
It is. It's like the worst cleanup.
Yeah.
And it's during the cleanup when you're gonna flick it and fling it somewhere that you shouldn't, like right there. Yeah, this is not what you want to do. Now here's the thing, some people will just take compressed air and be like, you know what, psh, and hit it, but then you can send it flying under the memory chips and stuff, and then that's where you'll end up with a problem. So let's see if I can. Look at that.
It just trolls you.
Anyway, this is the process, and there is some that's made its way outside. See, like right here? What I'll be doing is I will just be soaking the shit out of this board in isopropyl alcohol to break as much of that down as possible. Why'd I go all Midwestern? It's as much as possible. Oh, don't ya know? It's so, oh no, look at what, oh Bobby, look what you did. That's what one little drop of liquid metal did when I wiped it with the paper. It's so metal, bro. Something Steve's hair can relax to. Okay, this is what only a little bit of liquid metal turns into. But I obviously need to make sure I get every bit of this up because I really don't feel like having it make its way onto the new PCB. My fingers are burning. All right, so there we go. Clean as can be, clean as a whistle. But you might be looking at the core going, wow, Jay, that really caused some weird effects on the core. No, it didn't touch the core at all. This was one of my XOC cards. This is one of the cards that, is this the card I redid the wiring on too? I think this is the card I redid the, yeah, this is one of the cards I redid. Anyway, I lapped this. So what you're seeing right here are the sanding marks because I lapped basically the raised letters off of the die. And when you're doing XOC, clamping pressure and the tightest pressure between the XOC, like the LN2 pot and the die is really important. So to get rid of the raised letters, which is only like, I don't know, 1,000th or 15,000ths of a millimeter or something crazy like that. I don't know it's really low. It makes a difference. I think that's one of the reasons why this card was performing so well too, was the liquid metal plus the lap. You might see some discoloration around the side right here. Most of the nail polish has come off with the isopropyl alcohol. Although it's not nail polish remover, alcohol does break down the acrylic. So I kept hitting that with my toothbrush and my compressed air to get most of that off. So we're back to a pretty good state now where I can get the new block put on. But you know, this is kind of where this video sort of ends because I was curious, like the question really was, this is the first time I've ever run liquid metal full time in anything. And I was curious as to whether or not it would cause a problem. Now here's the thing, cards that are designed to use liquid metal, that are using it from the factory, i.e. the 5090 FE, have both a moat that keeps it from migrating where it needs to, like it keeps it from migrating to areas it shouldn't be touching, and two, an oxygen barrier. Because what accelerates the corrosion that gallium can cause is when it mixes with oxygen. And so they have like a rubber seal that would go on there too, and when you push it down, it actually squishes the air out and creates almost like a little vacuum. That is not what this was, clearly. So I just was curious if it was, did I cause myself an issue here? No, I didn't. This card has been through hell, and that's why I wanted to reuse this one and not my other cards that I have laying around, because it has survived the XOC. You can see some of my old solder marks right there. One of the ground holes is still filled with solder. There was no point in getting it out. I just took my posts out. That was where I connect my EBC2 to the voltage controller on the card so I could control voltage and droop and all that stuff when doing XOC. And then obviously it survived liquid metal for 7 months after going through all of the abuse I could put it through and me learning how to solder on it. That was the other thing, is like I had to learn how to solder on this guy. But anyway, I guess what we'll do, just to make this video have something interesting to it, I guess you did get something interesting. No ill effects happened because Thermal Grizzly considers their coatings and their resistance to gallium, which is evident. 2, the die can resist it just fine, and the card will survive if you keep it from destroying any SMDs or getting in areas where it shouldn't have gotten. What I ended up doing, just to make sure that absolutely none of that liquid metal that was kind of like getting its way out of where I wanted it to be, completely doused the board in lab grade isopropyl alcohol and let it sit there. And then I took my toothbrush and just absolutely scrubbed everywhere it could have possibly been. And then I repeated that process like 4 or 5 times before I hit it with compressed air. The compressed air allows me to let any of the alcohol that's formed and pooled underneath any of the chips get blown away. And if any of that liquid metal had still mixed with it, it would go too. I have no doubt right now that this board is completely safe to use. I have no issues with it. Like, I don't feel like, almost said LN2. I don't feel like any liquid metal got anywhere it shouldn't be. But you saw, the cleanup is tedious with liquid metal. Just because I ran it all that time without there being any ill effects, doesn't mean I couldn't have potentially ruined it putting it back together, because liquid metal got somewhere I didn't realize it should have been. And liquid metal can bridge pins and connectors. It can completely dissolve solder as well, so it could get on SMDs and then eventually those SMDs can fall off or break loose or, again, ground them. So it's quite literally in the name. It's liquid metal. It is as bad as if I took aluminum shavings and just sprinkled it all over the board, which I guess I could do now if I really wanted to, but I'm not gonna. So yeah, there's a good lesson to be learned there. So anyway, we're gonna go ahead now and move on to the installation of the core. The reason why I'm showing you making that sound, well, I didn't mean to drop my card right there, is the weight difference between these two cards is kind of crazy. I do feel like blocks have gotten, or I said card, the block. I do believe they have gotten heavier than they need to be. And I'm gonna weigh them right now when I get this block out of here, because it's a little crazy. 2.5 kilograms. It's pretty heavy. If I now take out the core, 1712. Still heavy, but absolutely lighter than I expected it to be. And I'm okay with that because that's a lot of weight to be putting on the PCB slot and the card sagging and any of that stuff. So I'm hoping that we won't have too much of a sag issue, because there is no anti-sag mechanism built into Skunkworks at all. All right, this shows what a piece of shit EK was for all them years. Look at this, all pre-cut thermal pads. And I remember a while back, I was like, why does EK not have pre-cut thermal pads? And it was like, because the labor is too much. So anyway, clearly Alphacool found a way to do it. So, 6 for height, Weissnest, Avis der secured. Safety instructions. Varmelten paste auf garden. Like, I can make fun of German, it's literally, my mom is from Munich, okay? All right, so this is showing where the yellow pads go. These are all 3mm thick, that's for backplate. That is the back of the graphics card right there. These are all 1mm thick. See, that is the best way to do it. You design the block Z-axis so that you use the same thickness thermal pad everywhere by just changing the heights of the components on the block, right? The highs and lows. Instead of like, I know I'm coming back to EK, but that's because I have the most experience with EK blocks for 2 decades. EK would have like, here's a 3mm pad for this area, here's a 2mm pad for this area, here's a 0.5mm pad for this area. So instead of having the block heights be like tight tolerances to where they needed to be, they were just like, oh, bigger gap, bigger pad. But then what happens is you have to account for the lowest common idiot. And what basically happens there is somebody puts a pad in the wrong spot, and then it doesn't make good contact where it's supposed to, i.e. your block no longer makes contact with the die like it should, because you put too thick of a pad, say, on the memory, and then you're overheating and stuff. So having all 1mm pads is so refreshing to see. And look, the blue pads, blue goes where that's showing. Yellow goes where that's showing. So this is having me apply the pads to the block directly, and then it's having me apply the back plate pads to the parts right there. Ooh, look at that. It's interesting that they're not actually having me touch the back of all of the POS caps and such. They're having me like use this square pad to go around that. That's interesting. I've literally never seen that before. I mean, look, even Der Bauer's touches the back of the POS caps, not the perimeter. So Phil wanted me to show you guys, this is the thermal pad wicking. Right, so in the first Skunkworks video, we showed you how in the back of the 4090, it wicked through the screws, right? But think of it as, it's a hot summer day, and this is your underwear, and this is the sweat. It just sort of wicks. Right? The swamp ass, yeah. Okay, so I'm not gonna take you guys along for the ride of putting all the pads and stuff down. I'm gonna follow the instructions, put it together right now. It's been a long time since I've actually used an Alphacool water block. Their core series stuff, I didn't get a chance to check them out in Computex, but I'm actually really pleased with their new designs. This is gonna match the block that's in there. That's the same series as this, so it's gonna kind of match nicely, because I'm taking that block out and putting it on this board in that system. So yes, these 3 systems are getting torn down, but it's okay. It's a labor of love. But pricing wise, real quick, I wanna point this out. Like, dude, I'm telling you, block prices are nuts. Even the brands you wouldn't expect to be expensive, like Bike Ski. I mean, Bits Power, yeah, I kind of expect them to be expensive, but like Bike Ski, Barotech, like those guys made a name for themselves by being the affordable brand. And then now that they're like $400+ for their blocks. So if I look up 5090 Astral block, this was $289, that. So more expensive than they used to be. Like it used to be like 120 bucks for a full cover block. $289. It has only 4 reviews, but still it's brand new. The EK Waterblock Quantum Vector 3 is $404. The super generic, doesn't even have a name, copper GPU water cooling block for 5090 Astral is $280. I'd much rather go with Alphacool because I trust that. What it is that I'm trusting is not that the material's good and that it's gonna wick heat. It's that they've done their diligence to make sure Z-axis heights are all clearancing all the parts that matter for all revisions of the board. It's happened where, and I think it's even happened to EK before, where they have one measurement wrong and it like squishes on a cap or something and causes big problems. That's an issue. Bits Power Nebula GPU block. That one, $429. Now here's the thing. Alphacool also has the Alphacool Core 5090 ROG Astral water block with backplate and the 180 terminal for $434. It's the same block, but it comes with that 180 terminal. So all that terminal does is attach to those fittings and then turn the fittings into a different direction. Why that is as $250 or $150, whatever the math turns out to be, is beyond me. Like that, no, it's more than $150, whatever. That makes no sense. Okay, the Barotech block is $272, that's not so bad. But even Corsair's Hydro X block is $444. And that has one of the ugliest designs of all of them, in my opinion. So you can see why I wanted to try the $280 block. This card under full load with this 420 rad, slim rad right here, and this 420 thick boy right here from Singularity Computers, in my gaming room, which gets very warm, kept the coolant at about 35, 36 C under load, and the card was topping out at about 45 to 46 C under load. That system right there, with 4 360s, barely keeps the block at 49 to 50 degrees, because that's thermal paste and not liquid metal, and not, I think it actually might be lapped, but it's not thermal metal, same thing. So I'm expecting the temps to go up on this, but that's okay, because I think even 50 to 53 degrees is fine, and still colder than the air cooler would be with no added noise. So there's still a bunch of micro bubbles in here, but you can see the temperatures, it's significantly warmer. It's about 5 degrees hotter than the Delta block with the liquid metal. And that's kind of expected, honestly. I mean, I do have it overclocked right now. It's at 3022 megahertz, 51 on the core, 50 on the memory though. Like, that's just better memory temps than I was getting on the DeltaMate, or the DeltaMate block. But I'm wondering if part of that just has to do with the fact that this is synthetic, and then those were like actual in games. But this is running just under 600 watts. So this is like the worst I could expect it to be. It doesn't perform as well as the Bits Power block, that's for sure. So I was telling Phil off camera, I'm like, well, now do I want to run the Bits Power block? But I have options, and you have options now to watch other videos, because this one's gonna be over in a sec. But yeah, I think, honestly, it's a perfectly fine block for the price. Like, it not competing quite as well as a block that costs almost $200 more than it, kind of seems reasonable. But is maybe 2 degrees, 3 degrees worth $220 extra dollars? Probably not. I have them, so I can choose. The only reason I'm not using the DeltaMate is not just because that color doesn't exactly match how I would want it to be in Skunkworks. It's the port placement being on the back of the card. Because I have the distro plate below it, I need to be able to get it up to the, you gotta get it up to the card where it needs to be coming through that plate. Otherwise it would look weird coming up and going around and back and to the other way. So we would have this distro plate that runs it all the way to the other end, only to have a tube come back the other way above the distro plate to get into the block, and it would just look stupid. So now I'm gonna decide if I'm gonna use this Alphacool block. Man, the amount of heat that actually comes through that gap right there, it's kind of crazy. But whether or not I want to use the Alphacool block, or the bits power block. Could potentially also be a mounting pressure thing, and let me tell you why. Those really thick backplate thermal pads. This is a sandwich installation. The block and the backplate sandwich the card. So it's gonna take time for those thermal pads to kind of compress, and as they can compress, I can turn the screws a little more and get a tighter mount. That could be one of the reasons why it's running a little bit warmer too. Like 52C right now, not unreasonable, but I have a 560 and a 280 rad right here, which guess what? Is exactly what this block is gonna be getting in Skunkworks. So it's not one of those like, I'm running a very unreasonable, unrealistic setup. It is gonna be in Skunkworks in a lower compartment with no other heat from the system affecting it. So this is theoretically the kind of cooling I should be getting in Skunkworks. So it's not unreasonable. It's not terrible. This room is also a bit cooler than my gaming room, so I would expect that to be even hotter in my office at home. And at home in my office, I only saw 46 degrees as the high. So it sucks to see the temps get warmer, but I just don't feel comfortable doing liquid metal again. I just don't. I don't think it's worth the risk. All right, time to get out of here, guys. Thanks for watching. I don't think it's a bad block for the price. I don't, honestly. I just don't think the other blocks for a couple of degrees cooler are worth the extra price, personally. So, all right, thanks for watching, guys. Skunkworks builds incoming. You guys already saw the first video, and then there's gonna be this one, obviously, and I still have a lot of teardown to do to get ready to build that system because I have to cobble it together from 3 different builds. So, all right, guys, thanks for watching. We'll see you in the next one.